All right, gearing up for that big SSLC science exam? Well, you've come to the right place. We're going to run through a super quick rapid-fire pop quiz to sharpen your knowledge on some key concepts. Ready to see what you've got? Let's do this. Okay, take a good look at this number, 72. Yep, that is how many days you have until the big exam. The countdown is officially on. So we're going to make every single second count starting right now. But hey, don't sweat it. You're definitely not in this alone. We're going to tackle some of the trickiest concepts from the syllabus, and we'll do it together, one question at a time. Let's see how you do. Let's kick things off with a little jolt of physics. We're talking all about currents and connections. You know, the stuff that literally powers our world. So get ready, here comes your first question. This is a classic, but it's so important for safety. Just think for a second about the electricity flowing through your house. What actually happens if you get this one simple but absolutely critical connection wrong? I'll give you a moment. And here's why this is so critical. The consequences are, well, they're pretty severe. The scariest part, even if the fuse blows, the appliance is still live. That means there's a real, terrifying risk of a fatal electric shock. On top of that, you could totally fry your equipment because the fuse just isn't doing its job. So what's the big takeaway here? It's simple. The fuse always, and I mean always, goes on the live wire, period. All right, we've talked about the flow of electrons. Now let's zoom way in to the bonds between atoms. We're going from the big systems inside your walls to the tiny little systems inside our food. Yep, it is time for your chemistry pop quiz.
Hydrogenation. I bet you've seen that word on a food label before, right? But what does it actually mean? What's the real chemical significance here? What is this whole process for?
The real magic here is all about transformation. Hydrogenation takes an unstable, unsaturated compound and basically makes it stable and saturated. So what does that mean in the real world? Well, it means turning reactive fats into less reactive ones, which is a huge deal for increasing the shelf life of foods like oils and spreads. Of course, this process can also create trans fats, and that's a whole other health conversation, but it all starts with this fundamental chemical change. And this right here shows you exactly what we're talking about. Over on the left, you've got pentane. Notice how all the carbon atoms are connected with just single lines? Those are single bonds, which makes it saturated. Now look over at benzene on the right. See those double lines inside the ring? Those are double bonds, making it unsaturated and more reactive. So hydrogenation is the process that breaks those extra bonds to make a compound more stable, more like pentane. From chemical structures to the most complex and amazing machine of them all, the living body. So let's dive right into your biology pop quiz.
Okay, I've got a two-parter for you on this one. First part, what exactly is a reflex arc? And for the second part, why is this system so incredibly effective, so vital for survival, not just for us, but for tons of other animals too?
So let's start with a definition. Simply put, a reflex arc is just the pathway that nerve impulses travel along to create a reflex action. You know, like when you pull your hand away from a hot stove without even thinking about it, that's the reflex arc at work. It's like the neural superhighway for immediate responses. So why is it so effective? Well, a couple of big reasons. First, the brain's thinking process, believe it or not, just isn't fast enough for those split-second reactions you need in an emergency. And second, think about it. A lot of animals don't even have the complex brain network needed for that kind of deep thought. So this reflex arc is a super efficient, life-saving shortcut. Okay, we've covered a lot of theory. Let's get practical with a skill that often comes up in exams. It's time to put your anatomical knowledge to the test with a little drawing challenge. So here's the challenge. Draw the structure of the human heart. But wait, there's more. You also have to accurately label two specific, very important parts. Can you visualize them in your head already? Let's break this down. First up, the superior vena cava. This is a big one. It's the main pipeline bringing all the used, deoxygenated blood back to the heart from the upper part of your body. Just think of it as the main return pipe. And second, the left ventricle. This is the absolute powerhouse of the heart. It's the strongest chamber, and it's got the massive job of pumping fresh, oxygenated blood out to your entire body with every single beat. Wow, we've really covered a lot of ground in this quick session, haven't we? From the wiring in our houses all the way to the wiring inside our own bodies. So let's bring it all home with one final key takeaway. So, as you go into these final 72 days, just remember this. All this work, all the studying, all the practice, at the end of the day, it's all about one thing, making yourself proud,
You can do this. You've totally got this.
And I'll leave you with one last question to think about. As you keep preparing, which of these amazing systems, the electrical, the chemical, or the biological, which one just blows your mind the most with its complexity? Is it the invisible flow of electricity, the way chemical bonds can create something totally new, or the mind-bending speed of a biological reflex? Keep that curiosity alive. It's your best tool. Good luck.